Hey guys, here is a partial fractions problem, and what I'm going to do is I'm just going to do a few individual ones over the course of the next few days, upload them, and within there you'll get the idea of how to do all of the different cases. So this is just problem number 18 I picked out of your guys' homework problems, and the first thing we need to do would be to factor the denominator, and so I'm going to factor this as x and x, and I think 5 and 3 will make 15, and if I add them they'll get 8. So this now right here is what I'm really trying to do the partial fractions on. So I'm going to start a new line and say 4x plus 3 over x plus 5 x plus 3 equals, and I'm going to say that it's probably something of the form, since each one of these are distinct linear factors. So they're linear factors because each one by themselves would be a line. That's mx plus b, and that's mx plus b right there. So both of these are lines, and so they're linear factors, and they're distinct, meaning they're not the same. So they are totally, completely different in their own right. When you have that case, you want a partial fraction of each piece of that denominator. So I'm going to take a constant a over that first factor in the denominator plus b over the second factor in the denominator. Now that you have that, every single problem's done exactly the same from here. The very first step that we're going to do is clear the denominator. So I'm going to multiply both sides by x plus 5, x plus 3. Multiply this by x plus 5, x plus 3. And here, everything cancels. On the left side, we just have 4x plus 3. And on the right side, when we distribute, so this will distribute in there, and when I distribute that piece, the x plus 5s will cancel. And so what I'll get is a and x plus 3. So over here I've got a x plus 3 plus, and then when I go here, the same thing happens, but the x plus 3s will wipe, and I'll have a b and an x plus 5. So we have b and x plus 5. Now, from this spot, there's two different ways to go about this, and so I'm going to kind of do each one now on a separate page. So I'm going to take this, I'm going to copy it, and then here we'll paste it and move it down. So there's what we had right there in our piece, and like I said, I'm going to do this two different ways to show you. Since this is our first one, I'll tell you, and along the way you will learn my experience and why I like certain things better, certain ways of solving these problems. It depends on the situation that you're in, really. So one way is picking values, and that goes like this. So we have 4x plus 3 equals a parentheses x plus 5 plus b, or whoops, that's x plus 3. X plus 3 and b x plus 5. Okay, on this, since I'm going to pick a value, the value that I pick for x in here has to be the same value that works here, where we actually broke it down. And so, because this decomposition has the two partial fractions, the two parts of it, anything for a and b and x on this side will have to come out to be this on the other side. So whatever values I choose for x, it'll have to hold for all time. And so on this problem, there happens to be a couple what I call smart choices to pick for x. One of them would be, let's let x be negative 3. And if x was negative 3, here's what we would get. We'd get 4 times negative 3 plus 3 equals a negative 3 plus 3 plus b negative 3 plus 5. Now, normally you wouldn't always write all of that out. You can kind of figure it out in your head. I'll show you when we do the next one. But why did I pick the value negative 3? The reason is because look in here. You see negative 3 plus 3 will be a 0, and that will disappear. And if that disappears, I know x and I know x, so I will know everything in here except for b, and that will allow me to solve for b. So zeroing out these factors is the smart choices for what to choose when you're picking values. Well, 4 times negative 3 is negative 12. Negative 12 plus 3 is negative 9. Then I just have negative 3 plus 5 is 2. So then I have 2b. So it looks like b is negative 9 halves. Okay. And then now I need a separate value. So this time I'm going to say, well, let's let x be negative 5. Now here's how I actually go about doing it. I go, okay, what's 4 times negative 5? Well, 4 times negative 5 is negative 20, plus 3 is negative 17. So on that side, we'd have negative 17. And then if I'm at negative 5 plus 3 is negative 2. So I would have negative 2a, negative 2a. And then negative 5 plus 5, oh, that's 0. Okay, so I don't need to worry about that. So that's how you do it differently. Like when I said plug it in on the fly, notice up here I wrote it with the negative 3 everywhere, and x appeared. And in this one, we just went back to here and we said put a negative 5 there. This side would turn out to be negative 17. This side would be the negative 2a, and this side just disappears, and so it doesn't show up there. It looks then like a turns out to be positive 17 halves. So now I know my a and I know my b in there. And that's the first way of doing it. And we'll put it together at the end in just a second. The other way of doing it, and this way you're not going to like it as much, but in certain situations it is the absolute best way to go about solving this. And so the other way is called equating coefficients. And each of you already intuitively know what this means. And what it means is this. If I happen to tell you that that ax squared plus bx plus c was equal to negative 5x squared plus 2x minus 7, and I asked you, if this was true, what would a have to be? What would a have to be for that to be true? And the thing is, you know now the a for a quadrant changes how wide or skinny the parabola is. And so, since that's the case, those would have to match identically if those two sides of that equation are going to be equal. And so the answer is that a would have to be negative 5. Then what would b have to be? Well, here's a b, and it's in front of the x, and there's a 2 in front of the x on that side. So I guess if b would be 2, they would be the same. And then finally, what would c have to be? Well, here I see c is a constant, and I see that negative 7 is a constant on that side. And so c would have to be negative 7. Do you see all we've done is we've equated the coefficients. We said the coefficient of x squared on this side has to equal the coefficient of x squared on that side. The coefficient of x has to be the coefficient of x, and the constant term has to match the constant term. So I'm now going to erase this because I need this room to work. But that's the idea behind equating coefficients. And so let's actually apply that to this side. So here's how that would actually come out to play. I would start with the 4x plus 3. But now what I'm going to do is I'm going to distribute. So I'm going to distribute there, and I'm going to distribute there as well. So a times x is ax, and then a times 3 is 3a, and then we have plus bx, and then plus 5b. And now what I'm going to do is I'm going to sort of like just group up like terms and then factor. So I see there's an x and an x. And so what I'm going to do is I'm going to list those first. And so I've got 4x plus 3 equals, I'm going to write ax plus bx. And then I've got that and that. Oh, so then I need a plus 3a plus 5b. Okay, and then the very last thing I can do is pull out an x. So I've got 4x plus 3 equals a plus b x. So both of those terms have an x in there, so I can pull it out. And then I have 3a plus the 5b. Okay, now that we have this, here's where it gets kind of cool. I see on this side what's in front of the x is a 4, and on this side what's in front of the x is an a plus b. Well, that means that a plus b should equal 4 then. And then I see on this side the constant term is a 3, and on this side the constant term, there's no variable with that. I mean, a and b are going to be set numbers that are fixed, and so there is no variable. X is the variable. And so my constant term there is 3a plus 5b. My constant term here is 3. So then it must be true that 3a plus 5b has to be 3. All right. The cool thing about this then is this is, and I'm going to write a little bit and erase. So this is a 2 by 2 system. And so we can use elimination or substitution to actually solve this system. This system is the same as x plus y equals 4 and 3x plus 5y equals 3. And you've done things like this already. So 2 by 2 systems, we know how to solve them. In order to solve this, I would eliminate the a first, and so I would multiply this side by -3 and this side by -3. If I do that, I get -3a minus 3b equals -12. And I'm going to keep this 3a plus 5b equals 3. And when I add, the a's disappear. So a -3b's plus 5b's is 2b's. And -12 plus 3 is -9. And so b is -9/2. And then once I know b is -9/2, I knew in the beginning that a plus b equaled 4. So a plus -9/2 equals 4. Or a, if I add this to the other side, a equals 4 plus 9/2. And 4 is 8/2 plus 9/2. That's 17/2. So I got a is 17/2 and b is -9/2. b is -9/2. A is 17/2. So there you go, class. There's 2 ways of solving that problem. One of them I call picking values, because we just said, let's let x be -3 and see what happens. Let's let x be -5 and see what happens. Notice over here, we never chose any choices for x. But we did say what's in front of x there has to be what's in front of x there. And the constant term there has to be the constant term over here. So when we finish, a is 17/2, b is -9/2. Here's the thing. We had this broke down for it. So my final answer for this, so this would be my final answer, I would say that equals, supposed to be a over x plus 5. A was 17/2. So this should be 17/2 over x plus 5. And then plus b, and b was -9/2. So we have plus -9/2 over x plus 3. And if I wanted to make it a little bit better, I could do this 17 over 2 x plus 5, and then minus 9 over 2 x plus 3. So I could make it like that. And so there's one problem right now to kind of get you started. And you can see and hear my way of thinking about it and how I look at it. And as we go through and I upload more of these, I will explain to you when is a situation where I would use pick values and when is a situation where I would use equating coefficients. And there is a time for this and a place, and there is a time and a place for this as well. On this problem, I will tell you, since we're talking about it, this problem would have been done by this if I was doing it. So this problem would be a pick value problem. The reason is because clearly there's a value that will wipe this out, and clearly there is a value that will wipe that out. And so because there is a right in my face, a -3 will wipe that and a -5 will wipe that. Because I can see that clear, I will use the pick values for this problem. All right? Take care, you guys. Hang in there. Bye-bye.